We're going to do a little this and that here in this particular video before we head over and talk about the Diffie-Hellman groups and what Diffie-Hellman does specifically. What I did during the break is I went ahead and rebuilt the VPN between 2 and 3 after letting all the connections drop and the SAs drop. And then I sent a ping after running debug crypto ISOCMP and debug crypto IPsec. And I did that off camera because the amount of scrolling is huge. So I just wanted to spare your eyes with that a little bit. And I just want to show you a couple of things here in this debug. So like I said, it's a really good idea to look at debugs when things are working correctly instead of just doing it when things are working incorrectly. So this is just some of the output. And again, don't think this is all stuff you have to memorize or, you got to go through every IKE phase here. Because as you're going to see, we talk about the two phases. But what you'll continually see, hopefully, as it's being built, is your phases changing. And if we go to the top here, you can see a slight mention here. I'm going to move this over just a bit of no state there at the upper right-hand corner. So we were there, but we didn't stay there very long, thankfully. And you can see, here's no state, and it's doing a retransmit. And what you'll notice a couple of times here is a port 500 being mentioned. This is UDP port 500, and it's used by IKE phase 1, or ISOCMP phase. So that's a port to watch out for when you're working with your ACLs. You put an ACL up, all of a sudden your VPNs aren't working. That's because you've got UDP port 500 blocked. So just a couple things here. And you'll notice here's that it's checking an ISOCMP transform 1 policy against priority 1 policy. Here are the values we put in for the non-default one. So that was being looked at that point. And let's see, you can see right there that we've got IKE process main mode going on, which is exactly what we'd expect. And we received a packet here from 10113, which is our peer. And just going down just a little bit further, you can see doing pre-shared key authentication. The debug even mentions that. And you'll see information here. We've got payloads, address 10112 at the top and 10113 at the bottom. So it's rocking right along. And then what we really like to see is SA authentication status authenticated. So that is always good. And we just zip down from here. And you can see we've got IKE process complete here. So let's see, right after that, all of a sudden we're looking at transform sets. So you can see that even though we see ISOCMP here, we've gone into phase 2. Now we're looking at the transform sets, and there are some values that we set, a couple that we didn't. And going on down, when you start seeing creating IPsec SAs, you know you're in good shape. And then finally down here near the bottom, you're going to see IPsec over here, SA created and SA created. So just a couple things to go on there, a couple things that went along with what we studied in previous videos. The main thing I wanted to show you was that port 500. That's a good thing to know about. And what about this SA Proto 50? That's a protocol number now, not a port number. What do you think that goes along with? What did we concentrate on when we were writing those transform sets? ESP. So 3 good numbers to know here, really. Going to give you one that we didn't see because we didn't use authentication header at all, but that was protocol, that is protocol 51. So again, UDP port 500, that's in use during ISOCMP phase 1. Protocol 50 is ESP, and protocol 51 is our authentication header. Just want to show you a couple of other things here and ask you a couple of questions about what you think is going to happen. Let's just run a show crypto map. And there's our crypto map that we used before. We see the interface using it. Everything's really the same as it was before. And let's just say I come in here right now and I think the name of that crypto map is CCNP. Or I looked at the config, because remember we did have a CCNP in there, it just wasn't the crypto map. So let's say that I go in here and I just go to that interface and I just say, okay, crypto map CCNP. Now we know there's no in-out here, but do you think the router is going to accept that? Is the router going to let me apply a non-existent crypto map to an interface? No, it will not, and it will actually be kind enough to tell us that the crypto map with tag CCNP does not exist. So that's when you say, Yes, it does. And then you go back and list your config and say, oh, no, it doesn't. So the router's kind enough to tell us about that. But here's something that might not be quite as obvious. That was the easy question. Let's say that we go in and we create the crypto map CCNP, and we'll do an IPsec ISACMP here. And we got the same message we saw before, this new crypto map remains disabled until you've got a valid ACL and a peer configured. So what if I just exit right there, or I get called away? It's like, oh, okay, I'll come back and do that later. And then I come in and it's like, okay, let me go ahead and apply that crypto map. Do you think the router would let me apply an empty crypto map, one that I have been told is going to be disabled? Well, let me do that one because that's CCNA. Huh. I didn't get any kind of message or anything. Let's give it a second. There's a usual console message. So even though the router told me that that crypto map is disabled, it looks like the router then allowed me to apply that crypto map to an interface. So let's run show crypto map again. And yeah, that's exactly what's going on. And notice this too. It's really interesting that we're giving this warning here, and we were given a warning when we created it, but there was no warning when we applied it. And it's telling you point blank, it's in an incomplete state, and by golly, it is even telling you why. Missing peer or access list definitions, and actually in this case, of course, it's missing both. So there are your default transform sets, but this is not good. So just a little bit of a warning there. We saw that the router will not allow you to apply a non-existent crypto map, even though I tried again with CCNA, and it didn't work. But once I created the CCNP crypto map, even though I didn't finish it, the router allowed me to apply it to an interface. So if you run into any issues and you just don't see what's going on in the config, always run your show commands, including show crypto map, because quite often, the show command will tell you, hey, you've got a problem and here's exactly what it is, and this is as good as it gets. That warning is telling you exactly what the issue is. Just a couple things to watch out for there as you move forward. Now, speaking of that, we're going to spend a few minutes with the Diffie-Hellman group. We're going to go through a little bit of detail about how exactly we're getting this secure key exchange over a non-secure channel, and then we're off to some GUI work. See you there.